Welcome. My name is Bob Tickelman. I'm excited to be your guide for this AZ500, Microsoft Azure Security Technologies. We are in the learning path for securing Azure resources using Microsoft Defender for Cloud and Microsoft Sentinel. We've got 4 learning paths, and we're in the first one on implementing and managing governance across your infrastructure. Across these 4 modules, we're going to take a look at Azure policies and the enforcement of governance at the Azure resource level. We're then going to take a look at the 2 tools of Azure Defender for Cloud and Azure Sentinel and how, in a layered approach, they provide this defense in depth to be able to not only control, but report on and manage your governance compliance requirements for security. So focusing on implementing and managing enforcement at the cloud governance using policies, we want to take a look at that MCSB, or the Microsoft Cloud Security Benchmark. We've got a long set of controls that we can then measure against to meet the compliance control requirements. Now, we're not going to go into all of the pieces, but we are going to look at the technologies that these MCSB controls can be measured against. And so I'll highlight the different Azure services and the type of control that you might want to enable at that resource. Before we get into Azure policies, I just want to have a whiteboarding session to talk about what a policy is. And this is a slightly different view than many of you may be seen as Azure, but I just want to describe it so that as I write on it, you understand what we're talking about. Starting from the very top, if you want to think of Azure as the world's cloud computer, we have the ability to interact with all of Azure through that different variety of whether it be the Azure portal, through templates, and we're going to take a look at that in this module. We have PowerShell CLIs. We then take a look at this thing called the ARM, or the Azure Resource Manager. That ARM layer is the interaction, regardless of how you approach it, through the graphical interface or other methods, that ARM layer is where we're going to be able to enforce policies. And that's why I brought it up here. So we're going to see how that gets applied. And another feature that a lot of people don't think about is the things called resource providers. They provide a lot of the magic that we need because as you connect to storage, you see the SPR, the storage resource provider. You see the SRP, the storage resource provider, the compute resource provider, the network resource provider, everything, there's a SQL resource provider. So all of the resources in Azure are obfuscated, separated from what you're actually thinking you're gaining access to through these things called resource providers. And then we get the infrastructure of Azure that's in that middle piece. I've ghosted it out because you really don't get to interact with that. You interact with the resource providers that access the information. And right down at the bottom is that piece that talks about, the actual devices themselves. And so this is going to go back, if you've watched other recordings, as I take a look at app services and the app service plans, the AKS, the Azure Kubernetes services, where we've been able to take Azure services and present them to you without having to manage the underlying infrastructure. So I'll introduce that here to maybe give you a view of what that looks like. So let's get into the whiteboard session. So when you want to interact with Azure, regardless of how you're going to do that interaction, you come through one of several methods through the Azure portal, and that's how I've been doing it through these various recordings, through the graphical interface. I can have access through either templates, PowerShell, CLI, or the SDKs that we have available to us. And I would say that these are probably going to be the recommended method, with templates being the best way. And we're going to talk about templates in this method to provide a safe, secure, repeatable, and scalable way to manage your resources in Azure. But we can access it in any one of these methods. So whether it be, say, something like that SQL database instance that I've talked about, whether it be a virtual machine, whether it be AKS, all of these services, whether it be Azure Storage, you're going to have to access these resources by coming through one of these methods that then access a thing called the resource providers. So for example, Azure Storage Well, your file might be stored someplace down below on some hard drive someplace. You access it, in my case, in the example, through the Azure portal. You went to the storage resource provider. It did its fancy loop through all of the infrastructures of things called scale units within inside of Azure and data centers, and then it actually drops that information on the file. So all of this layer has been obfuscated or hidden from you. Now, this is where policies apply. And we're going to take a look at what policies are in a few minutes, but you can now enforce any interaction, regardless of how you do it, through the graphical interface, through templates, that as it passes through this ARM layer, you can have a policy or a definition of how you want something to be created. That term governance that we talked about. So if you can say, I want a lock on something, or I want a naming convention with maintained. I want a resource to be only in certain regions, or I want it to be locked down. You can create this in a thing called a policy, and then as that object tries to get created, it gets measured against the policy, and then if you don't meet the requirements, it doesn't let you do it. And it warns you, says, I can't create this object because it doesn't meet the policy. Now, if you've already created an object, and you then apply a policy, on an ongoing basis, policies continually get reapplied against the scope where the policy is assigned. And if it finds a resource that for some reason didn't have the policy applied to it when it was created, because maybe the policy came in afterwards, it will report it as a non-compliant resource. And it can now do one of several things. It can report it to you and say, I'm not going to do anything. It can report it and try and enforce compliance. Or it can say, hey, it's not compliant, and the next time you change it, you can keep it the way it is. But if you're trying to change it, you're only going to be able to change it and bring it into compliance with the policy. So I want you to think about that level of interactions of what policies can do as we get back to the course material and see how all these interactions take place. And we get this layered approach of security within our Azure governance. So when we take a look at Azure policies, and a term called initiatives is something that we can work with within Azure to enforce a governance layer. Now think of this as a hierarchical structure. A policy is a single definition that lives in a term called JSON documents. So if you can define something, you can write that as a policy. Whatever it is, I want this feature to be maintained. Now, a single policy might be great. Maybe you've got a policy for how a virtual machine can be deployed. So in production, I want very large virtual machines, but maybe in development, I want very small. So I don't want you to over-provision the resource. So I could put a policy in place that controls how and what kind of devices you can deploy. Now, maybe you want to also have a policy for the networking component that goes along with that virtual machine that you're building. In this case, you don't build a policy for both of those pieces. You build them as individual policies, and then you combine them in a thing called an initiative. Now, in previous recordings, I might have talked about never assign permissions to an individual user. You're much better off to assign permissions or roles to a group, even if it's for a single individual, because organizations have people change, but the role typically doesn't. And so by just assigning a user to a group, assigning the RBAC permissions to the group, all I have to do if anything ever changes, I just have to take that person out and put them back in. The same thing in this example I would use for security policies and initiatives. By having a group of policies that control individual pieces, I can combine them together in an initiative, and I assign the initiative to control how I want the resources built. So again, around SQL, I can have a whole bunch of policies on how I want SQL to be managed and controlled. And then I can assign that as a single initiative. And if I need to use it across multiple SQL servers, I don't have to take the 5 or 6 policies and apply it multiple times. I apply the 5 or 6 policies into the initiative. I assign the initiative to the 5 or 6 SQL servers. So much easier. And that way, if a policy ever needs to change, or if I need to add something to it, I just add it to the initiative. And every place that the initiative is assigned, they now get that new policy as part of its group of policies in the initiative. So I would strongly recommend that you start to think about a hierarchical structure using not just policies, but this hierarchical structure of policies go into initiatives. Initiatives are the ones that are going to be used to implement that enforcement at the scope in which you define it. Now, across a number of recordings, we've talked about child objects inherit things from their parent. And we've talked about the different scopes. We did this for RBAC permissions. We took a look at and mentioned back then that policies. So we have the management group levels at that 7 layers or 6 that you control across 10,000. We then have the subscriptions. We then have resource groups, and then we have the resources themselves. Policies inherit from their parent object. So if you assign a policy at the resource group level, the resources get the policy from the parent. If you assign it at the subscription level, you can say that if this subscription is used to produce production resources, I could have an initiative that defines how those objects are going to be created in production versus how those objects might be created differently in dev or test. I could have the same policies with different values in those 2 different initiatives, one for production and one for test, and I can define them to maybe 2 different subscriptions so that as I develop things in production, they use the production subscription, and if I use things in dev, or test, I can use the dev or test subscription, and they get the same policy with different configurations. So there's a good example of how you might use these policies to enforce security across the entire management plane or governance plane within your organization. Now, I go back to other pieces, bringing it all together. We talked about the governance level. And so the governance plane starts at the tenant level. And I talked about how you should start with a single tenant because now you can have governance, like security policies, apply right from the tenant root and it applies throughout the entire organization so everybody gets the same policy applied to them. Where it became challenging is what happens if I have multiple tenants? Now, there's reason to have that, and we introduced in another recording how you could use the ability of a feature called Lighthouse to now have that enforced across multiple tenants. So we've got ways to resolve some of these features, but Azure policies and then marry them up with initiatives as a way to deploy them are a great way to enforce governance from a point from the time that a resource is deployed. And even if you come in after the fact, it's going to be able to report back, and you're seeing that in that graphic. You see non-compliant devices, and you can either force them to come into compliance or just report them as non-compliant, and then you can send messages to people to say, hey, you need to become compliant by this date. And then you can continue to measure that. I believe that at the time of deployment, and roughly every hour, you're going to get that evaluation of the policies and initiatives against those resources so you can actually see them being brought into date, or you can actually set it so that, yes, you can have it, it's non-compliant, but until, or if you ever want to change that object, you're going to also then be able to change it, but then make it compliant because the policy is going to be applied to those changes. Another feature to be able to implement this at scale is a feature called Azure Blueprints. Azure Blueprints are a combination of a bunch of different features. So we saw that we have policies that control the deployment of something, and a policy then lives in a initiative. An initiative doesn't have any policies. They have a group of policies, one or more, that enforce through the initiative. We talked about RBAC in previous recordings. Now, policies don't enforce RBAC permissions. We've talked about templates as ways to deploy something. What a blueprint does is allows you to configure templates, initiatives, policies, and permissions, the RBAC, a whole group of things to a deployment. Much like a blueprint as an architecture for a building that has electrical information, it's got building code requirements for structural, it's got plumbing, possible initiatives. So it's got all of the things brought together to actually deploy a final building. So everything is needed from electrical, plumbing, structural, all those pieces come together in a blueprint. Think of that here as a way to deploy templates to actually build the objects, the policies that are going to enforce governance against those objects that the template's creating, the RBAC permissions that are going to be assigned to those objects to control access to them. All of them can be put together in blueprints. Existing blueprint definitions and the assignments will need to be migrated to template specs and deployment stacks. So Blueprint artifacts are then going to be converted to ARM JSON templates or bicep files used to define the deployments that you've been using Blueprints for. So I want to give you that as a warning. You can use Blueprints now, but know that by a year from now, roughly of the time this recording, 2026, that you might want to move away from Blueprints specifically. So as I mentioned, Blueprints are a way to deploy a whole set of governance requirements to a deployment of a complete solution. You can deploy all the resources that are required through a template. So that's actually going to build the object. I can deploy a policy with that to control how those templates are going to deploy those resources to provide that governance. I can also include initiatives to have them deploy multiple policies together, as well as the slide is addressing, I can configure security settings, the RBAC permissions against those roles and those resources that you have. So it's a great way to create this full solution in the deployment of resources. Another tool that we've added to the tool belt of deploying resources is a feature called landing zones. And you're seeing several examples here. A landing zone would be, I'm going to use a non-technical definition here, that is like a blueprint on steroids. It is a way to go from, creating management groups and subscription levels. It's a complete deployment of an entire infrastructure, as well as potentially an entire tenant level configuration that you're working with to meet the landing zone requirements. Now, Microsoft has several template landing zones that you could use as a starting point to deploy your resources. Or you could go in and customize those and add specific resources to meet your specific requirements. Now, if you're interested in deploying an entire end-to-end solution inside of your tenant, this might be a great place to go in and work with it. Now, it's a great way to deploy that resource, but if you're going to only do it once and then just live with it, it's a lot of potential work, but it is a great way to take those templates, use it as a starting point, and then use either blueprints or other methods to be able to go in and customize those deployments to meet your specific requirements. So we've got a series of ways to deploy massive amounts of infrastructure in an automated fashion. Another tool that's in our tool belt to manage security in your environment is Azure Key Vault. And this has been mentioned in a number of other recordings as a key integral part of the deployment of things like whether it be Azure Storage, when we talked about your encryption keys, and you might want to store those encryption keys in Key Vault. So we want to take a look at what Key Vault is, and it's a regionally based unit of storage of secure information. And like its name hints to, it's a vault. It's a location to securely store several types of information. We often talk about it stores certificates, secrets, passwords, and that kind of information. Now, what's the difference between a password and a secret? Somebody will always ask me, I just say it's the length. So whether it's a certificate generated from a certificate authority, whether they be keys, whether they be passwords, all of that information can be stored in a Key Vault. Now, we're not here to teach about Key Vaults and how to build them, but I would strongly recommend, and it is the Microsoft recommendation, there is no price for a Key Vault. It's the use of the Key Vault that has a charge. So the recommended use, and something you may want to monitor for, is you don't want to put a bunch of secure information into a single Key Vault. So you don't put 5 different keys with different certificates, because if the vault gets compromised, all of the resources in the vault get compromised. So what we often recommend is if you have passwords, or if you have certificates, maybe you need several certificates. We took a look at the storage account. You need a SAS token to get access to the storage account possibly. And the encryption keys, you might want to put those in different storage accounts, because if one gets compromised, all of them are not going to be compromised, because having 5 different Key Vaults, each with one piece of information, is no cost difference than having one Key Vault with 5 pieces of information in it. So from a security perspective, more Key Vaults would be a more secure model. And it may be something you want to then monitor for in your governance and compliance, is to say, hey, who's accessing those vaults? How often are they being accessed? Hey, why are 5 different services accessing that vault for 5 different types of information? That might be a trigger that you might want to dissipate that use of that one key vault across maybe more. So Key Vault is a great way to secure this information. And as opposed to sending it to people, we talked about in the previous recording, that you don't want to send somebody information, say in an email, because now you've got it in your email, someone else has it in their email. If your emails get compromised, the key or secure information is now compromised. You want to actually just give them the ability to access the Key Vault. And if you use especially things like managed identities, you can actually have the application have a managed identity. You authorize the managed identity to come to the Key Vault for the application. It gets authenticated using Enter ID. It has the permission to read the resources in the Key Vault. It extracts that information, uses the information, and then it's gone. So it's not written into the code, or it's not in the config files for the application. It accesses it when it needs it. And one of the other nice benefits is, not only is it securely accessed, you now have a record of what used it, when it used it, so you can now monitor that access as you go along. So Key Vault, a great secure feature that you may want to make sure that you're monitoring for and enforcing the use of throughout your secure infrastructure. Now, there's two versions of Key Vault. There's the standard Key Vault that we'll talk about in just a few minutes, and there's one that supports, in that second bullet point, a thing called an HSM, or Hardware Security Module. I always think of the Mission Impossible movie, of Tom Cruise dropping into, a building, trying to get access to some information. If a person was trying to compromise the Key Vault, they would literally have to find which data center in which region, that information is stored. They would then have to find which server that information was on, and they'd have to steal the entire server, because if they were to do this remotely by trying to access the keys, if they didn't have the hardware security module connected to the key and its use, it's not going to be usable. So an HSM is a feature. It has an additional cost that goes along with it, but well worth that cost, and is often recommended in production. You might not want them in dev or test, but if you're going to deploy Key Vaults into production, you may want to consider the use of the HSM. Again, something you might want to put on your Windows Defender for Cloud in your benchmark testing and evaluations. You're going to check to make sure that they're being used and configured in a specific way. So when you take a look at Key Vault as an object, like everything in Azure, it's got that RBAC, or the IAM, the role-based access control, the identity access management, that ability to go in and control who has access to it. Now, you want to think about two areas of they talk about data planes and management planes. So how do I control the network access to these? And so there's the management of the vault, and then there's the use of the vault. So you might want to have different protections of, who can manage it. Maybe you're going to have it from secure internal IP addresses only, when you might have a publicly available application trying to access the information. So the data plane versus the management plane, you want to consider that from a security perspective. But you also want to manage the two areas, the vault itself, who built the vault, who manages the vault, who reads and accesses information in the vault, and then you take a look at the information in the vault, who put the information in the vault, who reads the information in the vault. So those are the two different kind of planes you want to take a look at, and this gets into that separation of control I've mentioned in other areas. For example, you may have one organization or person create the vault. They have the ability, as the owner of the vault, they have the ability to change the permissions. And so maybe I create the vault and I give somebody else, we'll call him, Brandon. Brandon has the capability to manage the vault. So Brandon is going to put things in, take things out, manage the resources in the vault itself. I can't do that, but I can control the vault. And then Brandon says, hey, I've got this application that needs access to read the information. I would then give that access to the service security principal, or the system assigned managed identity that has the ability to read the information for the vault, because I have the permission to be able to change the permissions. So there's that separation of control at the vault level. Now, accessing the information inside the vault can happen one of two ways. You can create what's called an access policy. So once someone has access to the vault, and they have at least read permission to the vault, so they can get into it, they then can read the information based on a policy. And so you can then control the type of policy, because maybe I've got maybe a key that's in there, and I need one application to write the data to the vault, or write the data using that key, and someone else maybe needs read access using that key. And so we can now have different policies and the way that they can use the information in the vault. The other thing that I can do is I can elevate this up from a SaaS or a policy-based access. I can now use Microsoft Entra ID, that the application or the user of the information gets access to the vault based around Entra ID, and then the access to the resources in the vault are also going to be controlled through that RBAC permissions that you have, and that's what they're talking about here. I've already covered most of the information on this slide, and it talks about that, principle of authentication, authorization, least permissions that you're dealing with, and wherever possible, you want to elevate this to something like an Entra ID as opposed to the shared access signatures or the policies that you're working with. Vaults are available on network segments, and so all the features that we've talked about, creating firewalls, put checks in and NSGs, all of those components that you bring together for a defense in depth to access the information in the vault itself. We've done this in other recordings where you now come to the key vault. It lives in a network segment that you're going to associate it, and then you can then put network settings around that key vault. And it's one of the services, if you remember the term that we talked about, private link and private endpoints, or you have a service endpoint. So you could literally have on a different network segment your key vault, and if you have the service endpoint, it gets access to all the vaults, or if you want to give it a private endpoint, you could then give that projection of that key vault as an IP address onto the network segment that wants to access it. So there's a lot of different ways to be able to control the network settings for the vault itself. Here's the information that talks about that HSM feature. It does require an elevated subscription or an elevated deployment of the key vault to one that supports the HSM. There's a small extra cost versus standard key vault, but absolutely in production, I would strongly recommend that that cost is more than offset by the extra security afforded you by the HSM. Here's the feature that talks about enabling the RBAC capabilities now to gain access to the vault itself, and then being able to gain access to the resources inside the vault. So you can see that, configuring the vault access and then configuring the RBAC permissions to the resources in the vault. This is the summary slide. I mentioned this at the beginning, the types of information. You can have secrets, you can have keys, you can have passwords, you can have certificates. All this type of information, but I remind you that you don't want to put a lot of information into a single vault. If that vault gets compromised, all the information that's compromised, you want to actually spread that information potentially across for every environment and every resource use of that information. You may want separate vaults for it, and that's really kind of the goal of this slide, taking a look at it. With any type of secure information, whether they be keys, whether they be certificates, you want to rotate that information on a regular basis. Now, Key Vault is going to make this very useful for you because now the application doesn't have to be aware of that key rotation. They just know that they have to go get the most current information from the Key Vault. And then what you do is you manage the rotation of those keys through the Key Vault itself. And so all that monitoring that's available on the vault, maybe it's done on a time basis, maybe it's based on the number of accesses, whatever you want, you can now automate the process of key rotation and simplify the distribution of that updated information based around access to the vault, and not trying to give the keys to the actual resource itself and then trying to find a way to publish those new or the key rotation items to the resource specifically. Backup is always going to be an important part of that information. With your certificates, they're probably coming from a PKI or public key infrastructure. And yes, you can get key recovery agents to get this information, but backups are by far and away the best method to provide the fastest way to recover from a potential failure. So making sure that you have a regular and rigorous backup procedure. You also don't want to just set up the backups and say, hey, I'm done. You, on a regular basis, want to be able to recover that information to, one, make sure that you've got the skills to recover it, but also to make sure that the backup is working properly. So make sure that you have a backup and recovery process that's in place. You can monitor for it and make sure that it's being maintained, not just from an information perspective, but from a skill perspective to recover it. I can't tell you how many times I've gone to customers and they've asked me to help and assist in a recovery, and I go, hey, where's the backup? They give me the backup and there's corrupted or no information on the backup. Or they've actually caused more problems, doing the recovery because they've never done it. And it's the first time that they're doing it, and they end up wiping out the entire SQL server instead of just recovering the one SQL database, wiping out the entire SQL server, causing more issues because they recovered the SQL server as opposed to a database. So those are all important skills to make sure that you have to validate the information and validate your skills in both backup and recovery. As with everything, there's a set of controls that we have available to us, and we're going to cover more of this in our data protection plans. And we can now go through and use the Microsoft Cloud Security Benchmark to make sure that our backup and recovery procedures are in compliance with our expectations, to make sure that we have a full end-to-end solution from the creation, the distribution, the use, and the potential recovery of the information we're looking for. And repeating a lot of the topics we've already talked about, wherever possible, you want to have lifecycle management that says how long you're going to keep the backups for. Do you allow for soft deletes? And when we covered the storage accounts, we mentioned that you might be, instead of having to rely on a backup, you may want to have snapshots of data stores. You may want to have a soft delete capability for a period of time, so that if you get alerted that information got deleted, as opposed to running to a backup to recover it, which you still want to have, you might want to immediately just go to a soft delete and then recover that soft delete to recover the information backwards. So don't think that one replaces the other. It's this layered approach to provide a full set of skills that's available to you. So we've now covered and talked about the implementation and the enforcement through a variety of levels, through the creation of objects, using things like policies and initiatives. We've seen that we can deploy entire solutions with blueprints, bringing not just policies and initiatives, but templates for the deployment and RBAC permissions being assigned. We've looked at enforcing security using Key Vault as the repository to manage access to the secure information, whether they be passwords, secrets, or certificates, to gain access to that secure information in a secure manner, and looked at a number of different tools that we could then use to measure those benchmarks. So thanks for watching this recording, and I look forward to seeing you at a future recording.